Hello and welcome to the Chandara Academy. Sumsokon Mokan Chandara Academy. In today's video we are going to calculate the following limits. First we are going to calculate a, which is equal to the limit when x tends to 2 of x squared minus 4 over 2x minus 4. So let's first see if we have a real problem in x is equal to 2. In x is equal to 2 we will have 2 squared minus 4 that is equal to 0 over 2 times 2 minus 4 that is also equal to 0. And we have a problem because 0 over 0 is a non-defined form. So we are going to work this through. Okay, so for all x that is not equal to 2, obviously, we have x squared minus 4 over 2x minus 4. That will be equal, we can see it like that. Okay, we want to make appear some x minus 2. Why? Because we want the limit in 2. And this is the trick, make appear some x minus 2. We see that at the top we have some identity. Let's remember that a squared minus b squared is equal to a plus b times a minus b. Here we have the same thing with x and 2. This is equal to x plus 2 times x minus 2, because we can see 4 as 2 squared. And at the bottom we can see, because we want to make appear some x minus 2, that this is equal to 2 times x minus 2 as well. And here we can simplify the x minus 2 at the top and at the bottom, and we are left with x plus 2 over 2. And this thing has an easy limit when x tends to 2. This thing will tend to 2 plus 2 over 2, that is equal to 1/2. And so we can say that a is equal to 1/2. And we have solved the first limit. This was very easy when you get the trick to make appear x minus 2, and because this looks like we can make appear x minus 2, to be honest. Now the second limit, that is a lot more complicated. We got b, that is equal to the limit when x tends to 2 as well, of square root of x plus 2 minus 2 over 6 minus 3x. Okay, perfect. So what we see here is that when we will have x is equal to 2, we will have square root of 2 plus 2 minus 2, that is basically equal to 0, and at the bottom 6 minus 3 times 2 is equal to 0 over 0. Okay, so undefined form. So what we want to do is to work a little bit with that. So let's say that x is different from 2, where there is a problem. We got square root of x plus 2 minus 2 over 6 minus 3x. Okay, so what we want here is to make disappear this square root, because this is very difficult to work with this kind of square root. And we know that if still using the same identity, a plus b times a minus b, this is equal to a squared minus b squared. And we want this a squared to get rid of that. And so we will multiply at the top and at the bottom by the complementary, so the complement of this expression, that is square root of x plus 2, but this time plus 2 at the top, and we have to do it at the bottom as well to not change the equation. So square root of x plus 2 at the bottom as well. And this thing will be equal to, so here I have my identity, so square root of x plus 2 squared minus 2 squared. That gives us x plus 2 minus 4 over square root of x plus 2 plus 2. And this isn't very interesting, because this thing will be different from 0 when x is equal to 2. Okay, so this is very interesting because this does not cause any problem, times and we want to make up here, as I told you, some x minus 2. So here, times minus 3 times x minus 2. Okay, minus 3 times x minus 2 is equal to 6 minus 3x. And if we simplify the top, we have also x minus 2. This is not some magic, this is because we want the exercise, an exercise that can be solved by you, okay? So this is how the exercise is made. And so we can simplify those two, x minus 2, and we are left with 1 minus 1 over 3 times square root of x plus 2 plus 2. And this is very interesting because this thing has an easy limit in x tends to 2. Okay? When x tends to 2, this tends to minus 1 over 3 times square root of 2 plus 2, that is equal to easily 2. Okay, square root of 4, that is equal to 2 plus 2. And we've got this thing that's equal to minus 1 over 3 times 4, that is 12. And we can conclude by saying that B is equal to minus 1 over 12. This is a little bit more difficult than the first one, but always look how you can use when you've got square roots in values that are defined, okay, not plus or minus infinity. Try to look if you can get rid of some square root using these properties here, this identity. I hope you enjoyed the video. See you soon. Bye.